Hi, do you know any reliable lock system that is both affordable and secure?
Yes, but most systems today are expensive and have low reliability. To solve this issue, we've created a smart lock monitoring system.
Hi, I'm W. Patio from Wilmington High School, Massachusetts.
Hi, I'm Rashik Shavedi from Cupertino, California.
We're representing the United States of America.
Project objective. Most home and school doors have different mechanical lock designs. A solution to this is to have one system for all locks. Commercial locks are expensive, so our goal is to maintain affordability while considering security. Our process is to detect lock state using a magnet and a Hall effect sensor while publishing live updates on a web application and mobile device with recent history.
Our project progresses through 4 stages: sensor validation, retrofit testing on an existing lock, development of a custom lock prototype, and secure real-time monitoring using an interactive dashboard. So our key approach is to build the sensing concept first, validate it on real locks, then integrate communication and visualization.
First, we started by testing with the physical approach, where the Hall sensor was tested on a patio door lock using the Grow Beginner Kit. The sensor checks whether the magnet is close or moved away, while the display, LED, and buzzer gave feedback. So, as a next step, we extended our project by replacing GBK with an Arduino Uno R3 and powered the smart lock by connecting the LED through a breadboard and resistors.
In the third step, we transform the sensing concept into a complete lock prototype. The servo motor provides control movement, while the Hall sensor verifies the lock position using a magnet. The OLED display gives immediate status feedback. This demonstrates that the same platform can retrofit existing locks or support the development of a new, low-cost smart lock. In the final stage, we established the IoT communication architecture, replacing the R3 with Arduino R4 Wi-Fi, which publishes each locked or open event to the smart lock status using MQTT topic. Mosquito acts as the broker, routing these lightweight messages to Node RED. The Cloudflare tunnel then provides encrypted HTTPS access through TLS without exposing router ports. As shown in the video, we use Node RED, which converts the incoming lock events into a practical monitoring interface. It updates the live status, records each event with a timestamp, stores the history, and generates downloadable CSV reports. The responsive dashboard allows users to securely monitor the lock and review its activity from either a laptop or a mobile device, as presented in the slide.
Through this process, we have faced several challenges, including unstable sensor readings, Arduino R4 resetting issue, a steep IoT learning curve, and limits of free cloud services.
We solve these issues through software filtering, logic checks, firmware recovery using hard reset, and extensive testing. The details of each troubleshooting step is provided in the description.
The estimated cost of this project, even after looking at the maximum total prototyping cost of our lock at around $56, it is still considerably affordable than the ones found commercially, making it optimal for public use.
We have shared all of our data, code, and resources on GitHub, so students can learn from this project and developers can build on it. We hope to keep improving the system and make it usable in the real-world applications. Thank you.